Okay, hello. No more sweater arguments. All right. Okay, so chapter 5 is about basic statements. So that's what we're going to be talking about. Um, and I realize I've kind of like, I think I've kind of like done my part to obscure what basic statements are by kind of using that phrase in different ways as we went along rather than always in Popper's way. Um, but hopefully I can clear it up today exactly what's going on. So, I mean, so basic statements, correspond sort of to protocol sentences. That is, or observation sentences, right? These are the sentences that are going to be used to test scientific theories. Um, and actually, um, just to introduce this one more time, they're going to be used in two different ways. One is to decide whether a given theory is falsifiable. If I didn't introduce any extra eyes. Anyway, and the other is once you have a theory that's falsifiable, to actually falsify the theory. Um, And once again, for this purpose, we're looking at all possible basic statements, and we want to know whether uh, uh, the theory rules any of them out. Whereas for this, of course, we're looking only at the basic statements that have actually been accepted and see if any of them are the ones that the theory rules out, roughly speaking. But remember, already last time, Popper was saying how uh, in this case, finding one basic statement that would rule the theory out shows that it's falsifiable. But in this case, finding one basic statement that apparently does rule the theory out is not enough to falsify the theory. Um, right. So I think I'm going to go into some stuff that I wrote before or I've said before, but try to get it more clearly. Um, um, and like that is talking about the logical situation which applies to this and the logical situation which applies to this, right? We're, again, by the logical situation we mean basically thinking of the theory and its consequences as a bunch of statements and asking what the rules of logic, what we can get from what. um, Therefore abstracting from the methodological principles that are needed to make this actually useful. Uh, so, um, right. So I guess I'm gonna list these because there's only two. It's easy to remember. All right. So the theory looks like this, and um, so I think, I mean, Popper hasn't always emphasized this, and I've most more or less completely ignored it. But is where K ranges over space-time coordinates, space-time positions. Um, that is, in Carnap's terms, we're taking as the basic object space-time positions, and everything else is going to be a predicate, is going to be like a concept or a relation that applies to space-time positions. And Carnap himself, I mean, I don't think we read anything where this comes out, but Carnap himself is fond of this kind of position language. Uh, uh, I mean, for one thing, when you start discussing modal logic, it's depending what you think about space and time and whatever, you may be able to avoid questions about what happens when certain objects only exist contingently or whatever, if you think that space-time positions all necessarily exist. And the only thing that's contingent is what concepts apply. Okay, but never mind that. That doesn't have something to do with purpose motivation there. Maybe it does actually. But anyway, if it does, I'm not going to try to figure it out now. So, right. So, um, this, thinking of it this way makes it definite what kind of things the concepts are supposed to apply to, predicates are supposed to apply to. And so, like, rather than saying, A means is a swan and B means is white, we're going to say A means there's something at K that's a swan, and B means there's something at K that is AK means something at K is a swan, and BK means something at K is white. Okay, and so the theory implies that is, this kind of statement can be derived from the theory. And, once again, so like, I think Popper just says, this is what theories look like. And he calls this an all statement. And and this is at least as close as you can come in modern logic to reproduce the universal judgment of Aristotelian logic. Right? Like all A's are B would be the Aristotelian universal logic. So instead of that, we say everything that is A is B. Okay, so anyway, the theory implies statements like this. Implies every statement like this. Where now, again, C is the name of a space-time position. Do space-time positions really have names? I think this is part of the reason why Popper later wants to switch from syntax to semantics. If everything is supposed to be how you can write all the statements like this when you have this, there aren't enough statements like this for there to be one for every space-time point. But I probably shouldn't try to explain that in this class. But so, like, there's, even though the number of possible strings of a finite length in a finite alphabet is infinite, that is of finite length, not of a particular finite length. That's the finite. But the number of strings of finite length in a finite alphabet is infinite, and the number of space-time points is infinite. The infinite number of space-time points is more than the infinite number of strings. But again, I'm not going to try to explain that, and we don't really have to worry about that. I probably shouldn't have brought it up. So we'll just say, again, like this is the name of some space-time point, and every statement like this follows from this. So it says, if whatever is at C is a swan, then whatever is at C is white. Maybe I shouldn't have said whatever. That kind of makes it sound like there's another quantifier somewhere. Right? If the thing at C is a swan, then the thing at C is white. Or in other words, either the thing at C is white or it's not a swan. right? Again, like, I mean, you can use truth tables or if you know a deductive system for propositional logic or whatever to show that these are equivalent, but it's clear um, why they're equivalent, because if um, because uh, so, um, because the only way for the thing, if if the thing at C is not white, then this material implication is going to be false unless the thing at C is also not a swan, right? So you have one alternative is that the thing is white, and then it doesn't matter whether it's a swan or not. The implication will be good, right? But then if you don't have that alternative, you have to have the other one, which is it's not a swan. So right, so these say the same thing. Um, so in other words, the theory only implies a particular observation at places where there is no swan. Or sorry, the places where there is a swan. Um, um, at places where there is a swan, and therefore this disjunct is false, then the theory tells you you should expect to see something white. But in the places where there is no swan, and therefore this disjunct is true, the theory doesn't tell you what to expect. And uh, um, the theory doesn't imply that there are any swans. Now, this is actually a difference between the Aristotelian universal judgment. At least this is the way it's usually understood what happened. The Aristotelian universal judgment does like when you say all swans are white, that implies the existential judgment. Some swans are white. So in the Aristotelian logic, when you say all swans are white, you imply that there are swans because some of them are white. Some swans are white, right? But in modern logic, you don't, right? This is true. This um, um, statement is true if this is always false. So since the theory only says anything about what you'll see at places where there is a swan, and the theory doesn't imply that there are any such places, um, the theory doesn't imply any observable results. Right? That is, it only applies results under conditions that, as far as the theory is concerned, may never hold. Therefore, it doesn't imply that you actually that any actual observation. Um, but to put it in a positive way, this means the theory does imply an observation given a certain initial condition. Right, the reason the theory doesn't imply any actual observations is because the theory only implies observations given initial conditions, and the theory by itself doesn't tell you whether those initial conditions will ever hold. But if the initial conditions do hold, then the theory implies something. So now, like in this picture, in some ways, like this way of putting it makes it sound much more complicated than it is, right? I mean, this is just another way of saying like, um, you know, obviously, to contradict this, you need to find a swan that's not white. So you need to find a swan. And until you find a swan, you don't know what to say about this thing, right? Um, but um, but I think uh, Popper goes into some detail here because he wants to illuminate what the logical asymmetry is that makes his view different than the inductivist view. And um, so okay, so the basic statements. So in this example, for it to for it to be for it to be relevant to the question of whether this theory is empirical, these have to be basic statements. So basic statements, I mean, have this form that they just apply a predicate to a certain place. Um, but of course, that's no good unless you restrict what kind of predicate it can be. Right? Because, for example, you can define CK to mean you could define the new predicate C to mean this, right? And yet that doesn't make this a basic statement just because you've compressed everything to one, just so that it looks like this. Like sometimes Popper says a basic statement has to be of this form or something like that, but it's misleading because it's not logical form. I mean, you might call it what Kant calls transcendental form or something like that. But anyway, it's like you can't tell by what symbol, uh, in what order, what type of symbols are written. You can't tell from that whether you have a basic statement or not. So like this predicate has to be an observable predicate. And, this predicate, again, is not an observable predicate because uh, um, you can only tell whether it applies by checking places where there are swans, essentially. Is that right? It's kind of weird, actually. What?
Isn't that kind of like a disposition statement?
It's kind of like a disposition statement. Although, yeah, kind of like it. But this is a material implication, not a counterfactual. Uh, but um, right, no, okay. So if there is no swan there, then uh, I mean, every place there is no swan, this is true. So it is kind of observable. Now I'm getting confused. Kind of what I was thinking. Yeah.
Well, what the hell is observability?
Well, so that's the interesting point that I'm trying to get at, but I'm getting stuck on this foreign point. Yeah.
So even if it's observable, like, what's really stopping you from making a theory that hasn't been observed and like we don't really have any evidence for? Like,
I guess, okay, so I mean, I think, sorry,
Sorry,
I'm kind of like getting back to rather than answering your question. The point is, at every place where there isn't a swan, yes, this is true, but so is this. Right, so like this so-called observation doesn't tell us which of these predicates applies at that place. Now, I mean, I guess you could say, well, it shouldn't because those predicates are not inconsistent with each other at that place. But Um, yeah, something more precise needs to be said about this, but I'm gonna skip over it since I don't know exactly what to say right now. But I mean, you get the general idea, right? Like, I mean, the question is how to work it out in this terms of symbols that that um um if you were an inductivist and you thought you could go around building up evidence for this theory by observing all the places where this was true, you would be out of luck because unless there's a swan, places where this is true are also places where this is true. And so you would be building up evidence both for the theory that all swans are white and for the theory that all swans are not white. And so you wouldn't be able to count those instances as justifying instances for your theory. Right? That is, they don't favor your theory any more than, so to speak, the opposite theory. The opposite theory is not the negation of this theory, but the theory that says the opposite thing about swans. Right? And you couldn't use these instances to build up evidence for one as against the other, and so they'd be inductively useless. It's all right. So I mean, I think like how exactly to get that back to the idea that therefore that predicate C I wrote is not an observable predicate is maybe complicated, but that's the basic idea here, right? And so I mean, uh, um, what is an observable predicate? That was the interesting question that I forget who asked this now, but anyway, right? That was the interesting question. What is an observable predicate? So Popper doesn't define observable, and he says observable can't be defined. We have to take it as primitive. It can be given a psychological explanation. I guess an explanation here means, and I should have checked what the word is in German, or actually, does he even use the word explanation in English? I didn't put it in quotes in my notes, but it's too late to figure out now. It can be given a psychological explanation. We can say, well, an observable property is the kind of property that people observe, where observe is a name for a psychological process, right? Or Popper says it can be given a physicalistic explanation that it has to do with the motion of macroscopic bodies, whatever that means exactly. You might think that the term macroscopic smuggles psychology back in, because macroscopic really means like suited to our faculties of perception or something. But maybe macroscopic just means large compared to the Planck scale or something. I don't know. Anyway,
The Planck scale is absolutely suited to the kinds of things we can observe, isn't it? That's not good.
no, but all right, never mind. It's uh, so um, um, so those are explanations in the sense that um, uh, those may equally well be extensionally adequate, right? That is, it may be that the predicates we want to call observable are exactly the ones that people can observe. And it may be that the predicates we want to call observable are exactly the ones that concern the motion of macroscopic bodies. I'm not sure that Popper, I mean, he kind of seems to say that that's true. I'm not sure he really wants to allow that, or that it's even something that couldn't change or be relative to context. I mean, presumably he's going to agree with Carnap that in the right situation, something like a positron passed through the detector will count as a basic statement. Well, maybe that just means you have to look more into the psychological process of observation. What do you mean by that? In any case, you can give these explanations, but I think they're not suitable as definitions because they don't get at what observable actually means. So, I mean, if that's really Popper's complaint, he's obviously disagreeing with Carnap and Goodman and others about what we're looking for in a definition here. Because I mean, Carnap is happy to admit that a term has been given a meaning when you put it into a constitutional system with a psychological basis. And the same term has been given, I guess, the same meaning when you put it into a constitutional system with a physicalistic basis, as long as the extension stays the same. Well, so that's weird. The extension doesn't say the same. So you have to say, as long as it's true in all the same worlds or something like that. All right. Yeah, I think what's happening now is bad because I'm thinking about all kinds of stuff that I didn't think when I wrote down the notes, and I'm like trying to bring it out yes, on the fly. And I think that's good up to a point, but it's going too far. All right. So the point is, we can give ways of recognizing which predicates are likely to be observable and which are not, but they're not going to be suitable as a definition of observable. And what does observable really mean? Well, it really means the kind of singular statement we can expect everyone to agree about. And by everyone, of course, we mean everyone who's properly situated. That is, everyone who's present, so to speak. Right? Because a singular statement mentions a particular spatiotemporal position. And so it limits who's qualified to have an opinion about it. And that limitation itself is also, I think, maybe not definable in advance. We have to agree on that. Because it's different for different observations, right? Like how far away in space and time you expect people to be in a position to judge. That's the idea. So the basic statements are the ones that we expect everyone to agree on. And you can see from, you expect everyone to agree on because of observations. Right? You can see from this example that like when you put basic statements together using logical operators, you don't necessarily get a new basic statement. So for example, this is not a basic statement. And more importantly, I think Popper says that in general, the negation of a basic statement is not a basic statement. No, I guess not in general, it's not, but it's not in general the case that the negation of a basic statement is a basic statement, right? That is, sometimes both something and the opposite can be a basic statement. Like there's a swan here, there isn't a swan here, right? But sometimes one of them is a basic statement and the other is not. And this is importantly supposed to be such a case. So then, because the negation of this, that is the negation of this, is which is the same as and sorry, I'm not missing. Right, this is, what is this called? De Morgan's law, I think. That when you move you distribute the negation over the disjunction, it changes into a conjunction. So not this or this means that in order for it not to be true that this or this, it has to be true both that not this and not this. Maybe that wasn't helpful. Right, the only way this can be false, the only way this can be false is if both disjuncts are false. So when I add the negation here, I'm saying that the thing inside is, that is, the disjunction is false. The disjunction can only be false if both disjuncts are false. So that's why the negation of the disjunction is the same as the conjunction of the negations. Right, this tells you that this has to be false and this has to be false. Right, so, and of course, this is the same as just AC, so right, so the negation of this is this, that is, there's a swan at sea and there is not something white at sea. I'm sorry, I'm using B to stand for white, which is a little confusing, but oh well. So there's a swan at sea and there isn't something white at sea. That's the negation of this, and Popper says this is a basic statement. So this is not a basic statement, but its negation is a basic statement. And that's why, even though the theory could never be justified by singular statements, it can be falsified by singular statements. Or that is by basic statements, by observable singular statements, that is by basic statements, right? So observable singular statements are never enough to imply that the theory is true, but they are enough to imply that the theory is false, because the theory, the consequences that follow from the theory are not basic statements, but the things that the negation of the consequences of the theory, that is the thing that the theory rules out, are basic statements. Again, I feel like doing it all this detail is making it seem like a really difficult mathematical problem or something. But it's not difficult at all, right? We're just saying that, you know, the theory doesn't tell you what there are, what there is in the world at all, because again, the theory doesn't imply anything unless there are swans, and the theory doesn't imply that there are swans. Therefore, the theory doesn't imply anything positive, but it certainly implies that wherever there's a swan, it has to be white. That is, it certainly implies that this is false everywhere. So if we find this somewhere, the theory is false. Okay. And so what the theory does, another way of explaining what the theory does that makes it empirical, is the theory tells you how to get more consequences from the initial conditions than you would have got just from the initial conditions themselves. Yeah.
So I guess this is mostly just like a definitional question, but there is a white thing and there is not a swan, or there is a swan and there is not a white thing. Is that does that count as a basic statement, or is that a conjunction of two basic statements? Does
No.
a basic statement have to be a singular predicate?
Well, see, this is still singular. That is, it's right, there's no quantifier in it. Now, I mean, again, like you can't really tell it's singular by the fact that there's no quantifier in it, because by defining things right, you could hide a quantifier in it, right?
Well, there's two predicates, right? There's
yeah, but it's
white
still
and swan.
singular means it's just about one thing once, right? So that's, you know, and this is that, assuming that these are the right kind of predicates, I think is, I guess is the right way to put it. So if these are the right kind of predicates, observable predicates, then since there's no quantification here, this is a singular statement. And it is observable. So yeah, I'm pretty sure that the way, I mean, I think this is one of the things I've gotten confused about in trying to introduce this terminology on the fly before. I think Popper calls all of these singular statements, even though they're logically complicated like this, basic statements. And 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 after all, like, so I mean, here you could define CK to mean AK and not BK. That is, you could define a term that means non-white swan. And that would be fine because that's also an observable predicate. So that, right, so that I think it's really, it's the right thing to say that this is of the same kind as AC and BC separate. It's also a basic statement. Right, and so empirical theory rules out certain basic statements. And again, you can say the same thing by saying the empirical theory tells you how to derive things from the, right, because ruling this out is the same as implying this. So ruling out a basic statement is the same as telling you how to get something out of the initial conditions that you couldn't have got out of them themselves. The theory helps you get beyond them. Yeah.
Like, he explains observable, like, as being like the kind of singular statement you can expect everyone to agree on. But I guess, like, how many people seeing something confirms that? Like, is it only, there's only two people that see something, is that enough to say, and they agree upon it, is that enough to say that it's observable? And then to extend that, it's like, if you had enough people seeing something, when you eventually run into someone who disagreed?
Well, I think, so it's important. So remember, like, I'm still talking about falsifiability. And falsifiability is about possible basic statements. So possible basic statements, no one has actually agreed on, right? The number might be 0. So like, what makes it a possible basic statement is not that a lot of people agree on it, but that we expect people in a proper position to agree on it, right? Like, and we might be wrong. And what, you're saying, well, eventually we'll always be wrong. Well, I mean, I don't think, that would be true if there were always an infinite number of people in the right position to judge. Well, I don't know, maybe that still wouldn't be true. But anyway, you might think that was true if there were always an infinite number of people in a proper position to judge. Just like you think, you might think, to use this analogy that Popper introduces later in the chapter, like if juries were infinitely large, you might think that they never would be unanimous, that you would eventually find someone, right? But of course, that's not the way it works, right? I mean, usually when there's an observation, there's only a few people there, and it's reasonable to expect, although you could be wrong, right? It's a guess, it's a hypothesis.
Just knowing things in general, making these universal statements about stuff.
It is, and so there are differences, and I'm going to talk about the differences in a second, but it's true that he thinks that everything we say that expresses knowledge, whether it's a universal theory or a basic statement, it always has the status of a hypothesis that could be tested further, and we could be forced. We've agreed to give it up under certain circumstances. So that's as true of a basic statement as it is of a universal hypothesis. The difference is, going to be well, I'll talk about what the difference is, but anyway, yeah. So I think it is the same thing, yes. And And yeah, again, we saw this passage, it's in this chapter, I couldn't remember where it was, where he says that like, if it happened that scientists just couldn't agree on observations anymore, then scientific method would become absurd and the soaring edifice of science would soon lie in ruins, right? Because he's comparing it to the Tower of Babel, right? So, you know, so, and, you know, do we have some guarantee that that won't happen? No. We don't expect it to happen. And we can explain psychologically why we don't expect it to happen. And we could also explain metaphysically why we think it won't happen, but those metaphysical hypotheses are not testable, right? So that, you know, but uh, but yeah, we have no in the realm of our scientific knowledge, we have no reasons that would lead us to that would guarantee it won't happen. It's just a fact about us that we don't expect it to happen. Right. So, um, right. So I just said this. So the criterion that Popper gives it some, this is on page 65. In this way, we are led to demand that the theory should allow us to deduce, roughly speaking, more empirical singular statements than we can deduce from the initial conditions alone. Right? I mean, initial conditions by themselves, you know, at least if they're more complicated than this, logically imply all kinds of stuff, but you know, but what makes the theory empirical is that there's further things that we can only derive from them using the theory. And you know, so what I was just explaining basically is why that's exactly the same criterion as falsifiability. It's just a different way of saying the same thing. And so I think, like, to kind of wrap this up, the real asymmetry here is, or at least, I don't know, I should say this is the real asymmetry, but I think an illuminating way of understanding the asymmetry is that predicting something on a condition is not predicting anything. But forbidding something on a condition is forbidding something. Right? So saying on the condition that there's a swan, there'll be something white is not predicting anything because I didn't say that there's going to be a swan. Right? But saying on the condition that there's a swan, there can't be something not white is really forbidding something because it's forbidding a non-white swan. And I think, I mean, you can think kind of the same thing about like forbidding versus commanding, so to speak, right? Like if I command you to do X if you do Y, then I haven't commanded you to do anything because I didn't tell you to do Y, and therefore I haven't told you to do X either. But if I forbid you to do X if you do Y, then I have forbidden you to do something, namely X and Y. Yeah.
Just, I'm looking at it, but also on that page, he says something relevant to the question of like, how many people have to falsify it for it to be falsified,
Yeah.
which is he introduces, the other criterion of reproducibility.
Yeah. So
Take it as falsified only if we discover a reproducible effect, which falsifies.
right. So, but again, so far we're talking about falsifiability.
Yeah.
It's on that page, he's talking about falsification.
Yes, yeah.
And I guess, I mean, that's the same thing I'm sorry, what's your name?
Liza.
Liza, right. So that's the same thing I was saying in response to Liza's question, basically that so far on the falsifiability side, we're not assuming any number of people because it's just possible basic statements, so it could be zero. But then when it comes to the question of falsification, then of course it's gonna have to be some number of people, but, but there's no reason to think that, that won't often be satisfied. Right, that there won't often be, some number of people who all agree on it. I mean, the real issue is gonna be, I mean, so there is a real issue hidden in here, which is, and I think this is connected to what Kuhn is gonna say about this, that like, it's a normal state of affairs in science for some people to dismiss other people's observation results. So even though everyone who was in a position to judge agrees, other people say, we don't think they're reliable. And when people are fighting over whether a theory should still be accepted or should be given up in favor of a new theory, that's one of the things that's typically gonna come up. I mean, in the case of, and again, I don't know if this is true or, but at least people say that, you know, some like traditional, like Ptolemaic astronomers looked through Galileo's telescope and claimed that they couldn't see mountains on the moon, and they couldn't see the satellites of Jupiter. So there's a case where actually the people who supposedly were in a position to judge did disagree with each other. And that's, you know, I mean, that's more extreme and probably doesn't happen as often, but even that has happened historically. And yet the edifice of science didn't fall into ruins. Like, well, anyway, never mind that. So going on, right, so I think I've said what I want to say about the logical situation of falsifiability, and I already started to talk about falsification. But are there questions about this before I go on? I mean, it's not so much that these things I've written here could also be used to talk about falsification, but I mean, I wrote them here and talked about them in the context of falsifiability. What kind of things a theory implies and what kind of things it doesn't imply. And what kind of things we have to demand that it implies if we're going to call it falsifiable. Okay, so on the falsification side, the first thing to notice is, as I was saying kind of in a rush at the end last time, that if the theory has one possible falsifier, like this, then it's going to have infinitely many. Because since the theory has this universal form, right, if it implies this, it also implies this and all the others. And that's what Popper is getting at with that stuff at the end of chapter 4 with the circle and the, oh, I'm sorry, I noticed that my camera was not facing the right way. Right. With the stuff with the circle where he says, basically what he said, and why this is a circle, I'm not sure. Like, why couldn't it just be a rectangle? With this being K, and this being all the universal statements, but instead it works this way, that like, so these circles are supposed to correspond to time space coordinates. Right, so everything on the same circle is at the same, we're talking about things at the same place at the same time. And then the theories, no, wait, you can't draw the theories on here. So, okay, what Popper calls, and which is which. I think what he calls an occurrence is the whole line. So right, so there's three different things we're talking about here. There's the theory. Um, no, there's only two things. I'm getting confused. Right. So if the theory is this simple, then it only rules out one occurrence, or is it event? I don't remember, but the theory rules out everything along one of these lines, is the idea. So the idea is that the different things, the different points on this line are statements like this for different values of K. Right? So like if this is, in this room right now, and this is in the Andromeda galaxy 1,000 years from now, and all the others are different all the other space-time points are on here somewhere, right? So like this, and this is what Popper calls the event, or the occurrence, I don't remember. Anyway, that, this says, if there's a swan in this room right now, it's white. That is, in other words, there's no non-white swan in this room right now. And this says, if there will be a non-white swan at some point in the Andromeda galaxy 1,000 years from now, then it will be white. Or in other words, there's no non-white swan. There will be no non-white swan at that point 1,000 years from now, and etc. Right? So as you go along the radius, all the statements keep this form, but you just substitute different things for K. And so I mean, right. So an empirical theory always rules out one or more of these radii. Right? Because remember, like ideally in an empirical theory is this huge axiomatized structure, and we only get these lowest level observational generalizations at the bottom. And there can be lots of them, right? So it can rule out whole big parts of the circle or whatever. Although I'm not sure what actually is varying as you go along here. Like the concept. So I'm not sure what it means to go in this direction, but anyway, which again raises the question, why is it a circle?
Not sure why we needed. What's the utility of making it into geometry?
I think it's just supposed to help you envision it better.
I feel like I was getting it better before.
Yeah, maybe. Now that I talked about it for a while, maybe it's just kind of confusing.
Just saying that that like certain basic statements negate it, but
well, I think it helps him. It helps him because he wants to talk about other kinds of statements, like a contradictory statement. Wait, which way is it? A tautological statement doesn't rule out anything, and a contradictory statement rules out everything. Right, and he also wants to talk about existence statements. Anyway, but you're right, maybe this doesn't add that much. Hopefully, if you were trying to understand what he was talking about with that circle, I guess hopefully my picture helped you understand that, but whether you should try to understand it is a better question. Right. Anyway, but what I wanted to point out is that because the theory has strict universality, this is also true. Suppose the theory not only rules out, suppose the theory not only rules out this, but also rules out this, where D is some other predicate, some other observable predicate, but we're not saying which yet. Now, I mean, so first of all, presumably there always will be a predicate that works here. In fact, there'll always be lots and lots of predicates, right? So, like, if the theory rules out that there's a non-white swan in this room, it also rules out that there's a non-white swan and me in this room. Right? So if D means, and the thing at C is A, well, actually, I mean, C is really supposed to be a single space-time point. So maybe I should say, let D be that C is in the same room at the same time as A. Right? So C is some point in this room where there's no non-black swan. That's all the points in this room are like that. And so that, and the theory, in this case, correctly rules that out. There can't be any points where there's a non-black swan because there aren't any non-black swans. Then the theory also rules out that those points are points within a space-time region where I also am. Right, so the theory not only predicts correctly that there are no non-black swans in this room, but also that there are no black swans in this room if I'm in this room. But because the theory is strictly universal, it can't imply that unless it also applies the same thing everywhere. Right, and I mean, in this case, obviously you can check this is true, right? That is, the theory implies that everywhere there is no non-black swan, and therefore it also implies that everywhere there is no non-black swan with me in the same room. Right, so like it, you know, in the Andromeda galaxy, at this point, at this time, there's no non-black swan, and therefore there's also no non-black swan in a room with me in it. Now, I mean, there's no room with me in the Andromeda galaxy at all, but that's irrelevant, right? It's true that there's no non-black swan here with me in the same room. And this always has to work, right? That is, the theory, since the theory implies that this is false everywhere, it also implies that this plus whatever true thing is also false, right? Is that so? Did you still have a question?
No,
Okay.
I said, I said something, but it wasn't important. That it's a you've been saying non-black swan for a while, it's non-white swan, but it doesn't matter.
Oh, sorry,
It's not
non-white
something-
swan.
it
You're
could-
right. Yeah.
Logically, it's the same.
Yeah, no, I got confused by the thing that I said was confusing. And I'm using B to stand for white, whereas obviously it should stand for black. But anyway, okay, too late now.
We're a swan.
Yeah. So I mean, I should have used S and W, I guess, but oh wait, too late now. So so, but what that means is that any falsifying statement can be looked at as an instance of a falsifying hypothesis. That is, I just look for any other predicate that C makes true. And then, since the theory rules out every instance like this, the theory rules out this whole falsifying hypothesis. So, right, so that is the theory, and I guess maybe it's not clear that this is a falsifying hypothesis, but this is the same as saying, um, right, so the falsifying hypothesis is going to be something like, right, this says that not only is there a non-black swan at C, but there's a non-black swan everywhere that D is true. Sorry, non-white swan, right? So, so, oh, right, so this, okay, this is what I'm getting confused about. So what would be a falsifier for this falsifying hypothesis? Right, that is, how can I test whether, so this falsifying hypothesis is itself has to be testable. What could I use to test it? Well, so this falsifying hypothesis itself will be false if I find anything like this. Right, that's just the same, it's just doing this thing again. Right, but instead of A, we've got D and A as the initial condition. Right, so the falsifying hypothesis, so first of all, the falsifying hypothesis is definitely inconsistent with the theory, but um, um, the falsifying hypothesis says under the, so the theory says with the initial condition that there's a swan at K, this always follows. The falsifying hypothesis says with the initial condition there's a swan at K and D. So like there's a swan at K and Abe is in the room. The opposite follows. Right? So the falsifying hypothesis doesn't just say once upon a time somewhere there was a non-white swan. It says there's no non-white swans anytime Abe is in the room. Right? It's like an effect of me that I make the swans not white. Or to make it a little bit more reasonable, like suppose we observed a non-white swan in Australia, and we say, like, we take as D, C is in Australia. That is, this space-time point is in Australia. So, and then the falsifying hypothesis is gonna be all swans in Australia are not white. And you can always do that. And um, the the things that falsify the falsifying hypothesis are always going to look like this, right? So now this says, no, sorry, they're going to look like this. I'm not sure how this relates to my initial point about how the theory rules out everything looks like. Maybe it doesn't. Anyway, this is the part you need to understand and make it work, right? So anything that looks like this will be a counter instance to the falsifying hypothesis. That is, so for example, this might say K is in Australia, K is, there's a swan at K, and there's something white at the thing at K is white. And so the point is, I guess you could, all right, so you could put it this way. The question is, okay, so it's these that are called occurrences. Look at this picture is, I don't know. This is called an occurrence. This is called an event.
Wait, sorry. Hold on.
What?
When you were saying which one was which, I couldn't see past your hand.
Oh, sorry. The line is the event, and the occurrence is the point.
So observing an occurrence is an event.
Well, observing an occurrence is an event, but that's not what's relevant. What's relevant is that observing an occurrence is observing an event, but which event? So, like, if you take this as an observation of the event, AK, and so if you take, suppose I come somewhere and I find a non-white swan, right? So that at that point, C, this is the thing. At the point C, this is true. So one line that goes through this point, actually, the circle really is confusing because two radii can't go through the same. I don't know. Maybe the circle's a bad idea. The occurrence. So the occurrence, what happened at C was that at that time there was a swan, and at C, or sorry, there is a swan at C. That is at that place and time there's a swan, and what's at C is not white. So Popper in the notation, and see maybe the picture isn't good, but the notation he introduces at the end of chapter 4 is useful. So Popper calls this the occurrence P sub C, and then the event P would be like the whole line. So the event P is there being a non-white swan somewhere, sometime. I'm going to draw the circle one more time, even though it's confusing. But the universal statement rules out everything on this line. Existential statement is the same as the line. Right, because the existential statement says somewhere on this line there's something true. And this is good because the existential statement is the negation of a universal statement. But okay, never mind that. So the point is, so one way of understanding the event that's in question here is that the event, I can write it this way. This is the event, and then it has occurrences by where you substitute different space-time points for the variable k. But at this point, there's also other occurrences. Like this one. Right? That is, not only was it true that there was a swan at sea and that the thing at sea was not white, but it's also true that sea was in Australia and there was a swan at sea and the thing at sea is not white.
So an event can contain multiple occurrences.
Well, event instantiates more than one occurrence.
This is not good.
Yeah, exactly. That's why. No. Let's say goodbye to the circle once and for all. All right. So, right. So, these two occurrences are the same, but the corresponding events are not the same. So, saying that I need a falsifying hypothesis is basically saying that I need to report the observation of an event, not just of an occurrence. So if I reported the event as this, the falsifying hypothesis would be that no swans are white, right? Because any white swan would falsify the resulting falsifying hypothesis, which would be actually, so I guess the falsifying hypothesis would be no, this is the falsifying, right? So the falsifying hypothesis would be that all swans are not white, right? So in other words, if I find a not white swan and I report, I've observed the event that swans are not white, then my falsifying hypothesis is that no swans are white. And my falsifying hypothesis can be rejected by finding any white swan anywhere. But I can take the same observable circumstances and I can choose to report that as an instance of a different event. Right? So like in this case, the event I'm reporting would be that swans in Australia are not white. Right? So I say, instead of saying I've observed that swans are not white, I say I've observed that swans in Australia are not white. So now, like, you can't reject my falsifying hypothesis by finding a white swan anywhere. You have to find a white swan in Australia. So how do I know which event to report? Because it is dependent on which event I report. I'm going to be reporting something that is like, you have to do different things to test. So I'm like risking more or less depending on how I report the event. So I think the answer is whenever we observe something, we have to guess what event we've observed. If we want to use it to test a theory. That's the risk I have to take. So nothing is going to justify me in one or the other, right? I mean, I'm going to be deciding between two things that have the form of universal theories. Now, they're not necessarily strict universals, right? This one is a strict universal, but this one, where the falsifying theory is going to be that all swans in Australia are not white, is not going to be a strict universal according to Popper. Right? Because there's only a finite number of swans in Australia, and not everyone at every time and place can check what they're like. So actually it's a little ambiguous which of those is important. I think it's the second one that's important. I mean, yeah, because in effect, this does make an infinite number of predictions, right? You have to check every space-time point in Australia that is throughout the history of Australia. So there's infinitely many of them. But the point is, since they're all in the same space-time region, they're not accessible to all observers. So it's not a strict universal, but still it has the form of a universal theory, and that means it's not justifiable. Well, okay, now see, that's where whether it's finite seems like it could make a difference. It is finite in principle. You could check every swan in Australia and thereby justify it. That's kind of weird. Right? Like when Popper says the falsifying hypothesis is going to be there's a family of white ravens living in the zoo in New York. Or we could say black swans living in the zoo in New York. So the falsifying hypothesis is like all swans in family so-and-so in the zoo in New York are black or are not white. That's the falsifying hypothesis. So not only can you test it, you could also justify it by checking all members of that family. And yet he doesn't discuss that. He says the falsifying hypothesis, just like a universal theory, is there for testing. There's something that's hard to understand here, but in any case, I mean, normally the falsifying hypothesis, although it won't be strictly universal, will be, beyond the reach of justifying it by checking every instance. Like this one, all swans in Australia are not white. We can never be sure that we found every swan in Australia, even though it's a finite spatiotemporal region. I mean, especially because some of a lot of that region is in the past. Like that includes every space-time point that's in Australia now, but it also includes all space-time points that were ever in Australia. So it's going to be hard to, it may be in principle possible, but it's going to be hard to check that by examining every instance. So, so again, just as the initial theory, at least from a logical point of view, is just a guess. Now, I mean, again, just as in the case of the theory, there are psychological reasons why we believe it. There are psychological reasons, why we choose to report one event rather than another. Like in every swan you've seen before in Europe was white, and you're the first European to arrive in Australia. Because of course, the people in Australia are gonna have the opposite issue, right? But you're the first European to arrive in Australia. And you look around and you see a bunch of non-white swans. So it's likely you're gonna say something like, wow, in Australia, they're black. It's, unlikely you're gonna say something like, wow, within 10 feet of this tree here, they're black. But from a logical point of view, like one is no more justified than the other. They're both guesses. So, um, so not only we have to guess the theory, but when we're trying to falsify the theory, we have to guess what we're observing. And then based on that guess, we lay out a project for people to follow in order to defend the theory, namely, test my falsifying hypothesis. I think I spent way too much time. Oh yeah, I really have. Oops. All right. Okay, so like what all this comes down to is that in order to decide whether the theory is falsifiable or not, we have to decide what are the type of predicates that would probably lead people to agree on whether to accept them or not based on observations. But in order to actually falsify a theory, it comes down to even though, so accepting a single basic statement is never going to be enough to falsify a strictly universal accepted theory. The testing in the end all comes down to whether to accept a certain basic statement or not. So that is to complete the test of the theory. The way we complete the test of the theory is we guess what event we've observed. We test the corresponding falsifying hypothesis that rules out that event. And once we've tested it strictly, and it's passed all those tests, we accept the falsifying hypothesis, and therefore we reject the theory. So that's the process of testing the theory. And again, it comes down to looking at the instances of this falsifying hypothesis, looking at the things it rules out and seeing if we can find any. So seeing if we can find any basic statements that this forbids, but that we've accepted. And so the testing of the theory, even though it's not simple in the sense that we just look for one counter instance, does ultimately rest on decisions about whether to accept a certain basic statement or not. And the question is, what about the basic statement? In order to accept that, shouldn't we test it? Just like we tested the falsifying hypothesis to decide whether to accept it. Shouldn't we test the basic statement? So this is related to this thing that Popper calls Cruz's trilemma. So I think I'm going to erase all of this, talk about Cruz's trilemma. And I think I probably should have spent a lot less time talking about this and a lot more time talking about Cruz's trilemma, but it's too late. All right. So we'll try. Right, so there was this guy, Cruz, I think, I don't know, Jakob Cruz or Johann Fries or one of those German names. Anyway, um, I have not been able, I mean, I've never looked very hard. Popper unfortunately just cites Fries's whole book as the source for this. So, like, I've never gotten, or it's probably near the beginning. I probably could find it, but I would like to see Fries's own statement of this to see how close it is to what Popper said. Anyway, the one thing I do know, I have found out about Fries is that he was, among other things, I mean, he was a kind of naturalistic Kantian. It's kind of weird, but also he was one of the founders of modern German anti-Semitism. All right. Anyway, leaving that aside, so there's this trilemma. So the trilemma is you might think that you should only rationally accept a statement if you know a reason for it. That's how the trilemma starts. So you might think you should only rationally accept a statement if you know a reason that supports it. So Fries says there's three alternatives, or at least Fries, as reported by Popper, says that there's three alternatives. The first two alternatives agree that a statement can only be justified by another statement. So the reason for the statement has to be a statement, which seems reasonable. So one alternative then is infinite regress. Or circularity. By the way, sometimes you see something that's called a trilemma about argument or something like that, where infinite regress and circularity are two different options. But here, I think we're considering to be the same thing. That is, the point is, if it's really true that you always need a reason to rationally accept a statement, and the reason always has to be another statement, then either you need an infinite number of statements, or eventually you're going to get back to the original statement again. Right? Because you're only using a finite number, and once you use them all up, you're going to have to get back to the original one. And so you're stuck with infinite regress or circularity. Another alternative is to accept that, yeah, only a statement can be a reason for another statement, and therefore, since this is no good, reject the assumption that you can only rationally accept a statement if you know a reason for it, right? So this is what Popper calls dogmatism, and maybe Fries also calls dogmatism, but I'm not sure. At least that's what he calls dogmatism in this context, right? This means that you accept some statement without any reason. And so if you assume that the reason for a statement always has to be another statement, then you're stuck with one of these. Or there's a third alternative, which is that you think that there can be some other kind of statement, something else other than a statement that can justify a statement. And this is what Popper calls psychologism, because the other thing that's usually brought in here, I mean, so I guess in principle, this could be something like statements can be justified by statements or by erasers, right? It could be any random thing, but what's usually brought in here is our experiences, right? So you say you can only rationally accept a statement on the basis of another statement that implies it, or your experience of its truth. And here, I'm not going to have time to talk about this, but the German word for experience here is Erlebnis. This is as opposed to other German word. These are both correctly translated experience in English, but they actually mean different things in German. And in the original, Popper goes back and forth between them in this section, depending on what he's talking about. But he, I guess, gave up on trying to convey this distinction in English, and he translated them both as experience. And I guess the only thing I want to say about this, erlevenis is experience in a passive sense. It's right when you say, I had a terrible experience, for example, that means something happened to you. It's not something you did or asserted or tried or whatever. Whereas erfahrung is experience in the sense of something you go out and do. And it comes, I said I wasn't going to waste time on it. It's not a waste, but I said I didn't have time to talk about it, so I won't. All right, so anyway, right, so psychologism is the doctrine that's, since our statements can't all be justified by other statements on pain of infinite regress, some of them have to be justified by something else. What? By our direct experience of their truths. And so Popper agrees that a justificationist can't get out of this trilemma. And he says that Carnap basically accepts this, only he just translates it to the formal mode. Right? So rather rather than talking about it, well, at least in the Aufbau, maybe he actually kind of says this, but by the later period, he translates it to the formal mode. So rather than saying, I accept protocol sentences because I directly experience their truth, he says, we look for the kind of sentences that we directly experience the truth of, and we make it a rule of our system that you can write them down without anything else before them. That is, that they're axioms, basically. So Popper says, in effect, that's the same thing as this. You just change the way of talking about it. And Popper says that Neurath ends up accepting this. Because Neurath says, yeah, there are no statements that, so Popper, Carnap, at least in the Unity of Science, says that these statements can be written down without anything to justify them, and like further experience can't contradict them. Neurath says, oh no, sometimes you can delete the protocol sentences. But Popper says he gives no rules for when you can delete them. So basically, this just means you can decide which ones to accept and which ones not to accept. In other words, it's dogmatism. He doesn't give anyone as an example who accepts this, but maybe Spinoza might be an example of someone who accepts that. That all the statements that we accept are justified, but it's by an infinite chain. All statements that we correctly accept are justified, but it's by an infinite chain of premises that only God knows. All right, anyway, leaving that aside, so Popper's solution, again, is to say, we're not trying to justify statements. We're just trying to test them. So he says, in a way, it's dogmatic. Because when I introduced the statement, and now this applies to universal theories, strictly universal theories, it applies to low-level falsifying hypothesis, and it applies to basic statements. When I first introduce it, I give no justification for it. There is no logical justification for it. I'm just saying it. But so it's like dogmatism in that way, but it's not dogmatism because I'm willing to give it up if it's tested. And he says it's like infinite regress because there's no end to the procedure of testing. But he says that's okay because to make it rational to assert one of these statements, it's not necessary that it actually has been tested. It just has to be testable. Right? So, and this is related to things that Kant says about, but never mind. So, right, so an infinite series of justifying premises is no good because they all have to be true for the conclusion to be justified. Right, so they all also have to have been justified. But an infinite series of tests is fine because they don't all have to actually have been tested. So we don't need the whole infinite series to be in existence. It just has to be a potential infinity, as Aristotle would say. And it's kind of like this because now I'm out of time, but I guess I did get to the important point. I didn't get to talk about the jury analogy, which is annoying to me because I love that analogy and like try to figure out how it's analogous and how it isn't. But it probably doesn't matter for your understanding of Popper. So it's okay, I didn't get to it. But I'll just, so it's, Popper says, and it's also like psychologism. Because again, like the reason we put forward these statements is because of some kind of experience that we had. In the case of empirical statements, it's because of some kind of sense experience we had. In the case of, say, mathematical statements, it's because we had an experience of their necessary truth, right? Like we were absolutely convinced by them. So he says, sure enough, that's why we introduced them. But that doesn't affect their logical status in any way. Right? He says, just as you wouldn't write down in a mathematical proof, you know, when you get to step 3 and you write down this, and here you have to write your reason, you wouldn't write down, I experienced an overwhelming conviction that this is true. Right? That's no good as a justification in a mathematical proof. It is true, and it's important for why we like mathematical proofs and so forth, that we have these experiences, but it has nothing to do with justification. Similarly, in empirical testing, it's true that the reason we all agree on the basic statement is because of certain experiences we've had. But that doesn't justify it at all. And that's not what makes it rational to accept it. What makes it rational to accept it is that I'm willing to let it be tested if necessary. And I'm out of time, but yeah. There's a right, like strictly universal theories to be accepted have to have been passed strict tests. Right. So there actually has to have been some testing. But when you get farther down, you need less and less, basically, to make it rational to accept it. That's all I'll say. Okay. I will see you. Oh, so next week is a holiday, right? So I'll see you a week from today. Okay. Bye. It's Veterans Day, right? Yeah. Okay. Bye.